Alright, Crewton Ramone's House of Math, fooling around. We're just doing multiplication. And he's playing with dice. And how old are you again?
7.
I mean, I know this, but I just want to, so that you could, got the video on so they can tell that you're actually a 7-year-old. I'm not just making it up. Alright, so, first one we did was 5 times 11, which was way too easy, and then we did 15 times 11, and now we're doing 15 times 19?
Yep.
Alright. Tell me the answer. Oh, look at him.
285.
Is that the right answer?
Let me check.
Let me check. He's checking in his mind. So let's try it. Here's what I'm going to do. 100, 140, and 45. You look pretty correct to me.
Yep,
right?
That's right. I checked and that's right.
Yeah, there you go. He double checked in his brain. Now, can we draw a quick picture of that? There's my 100. Oops. There's my 100.
Should I make a picture of it?
There's my 50. There's my 90. Actually, I should do my 90 over here because it's that way and that way. There's my 90. There's my 50. Here's my 45 in the corner. There they all are, right? This is, these two blocks is the 140. That's the 100. All right. Good stuff. Roll again.
16 and 6.
16 and 6. How about 16 squared? What's 16 squared?
16 squared is 100. And then, so 256.
That's a number you should know, right? 16 squared, 256. Those are actually computer numbers, right?
Yep.
Hexadecimal. All right, so, and then you did, the first one was 16 times 6. That's easy. What's that?
That's 6 times 6, and then...
Wait, what's 6 times 6?
6 times 6 is 36.
There you go.
You said 6 times... Oh, 6 times 16. Oh.
Yeah, 16, 6. Yeah, there you go. Like I said, we've been playing blocks long enough that he's looking at blocks in his brain, I hope. Aren't you? Basically?
Well, sort of. A little bit.
Yeah, a little bit. Alright, well, give me an answer.
96.
Oh, I thought you were still working on it. Alright, you're correct. 16, 6 times is 60 and 36, right? 96.
Yep.
Alright. One more time.
A 3 and an 11.
A 3 and an 11. That's easy. How about 13 times 11? Or 11 times 13? That's super easy. 143, right?
Yep.
And see, that's the thing. You just do this, and then add those guys together. But you know why that trick works. It's not just a trick, right?
Yeah.
All right.
And then 2 times 3 is 33. So.
Yeah, that's easy. Okay, so I think these double-digit ones are pretty simple. Let's get. You want to get bigger?
Yeah.
All right. So roll 1.
6.
All right. We're gonna call that 26. And roll again.
6.
Okay, fine. We'll call that 16.
Okay. So.
You can hear them coming. Okay, so what have I got? I got this one, right? 200.
Yeah.
Boom.
Yeah, 200.
How many tens?
36.
12 tens and 6 more tens is how many tens?
Wait, 12 tens and 4 tens?
12 tens and 6. Where'd you get 4 tens? 12 tens and 6 tens.
And 6 tens, which is 18 tens.
18 tens, and then 6 times 6.
Which is 36.
Alright, we'll call that cross, right? We did this, and then we did that, and then that, right?
416.
So, what was it? 26, 16 times is, 300, 400. We're going this way, right? And then that's a 2, and that's a 6. Good job.
Yep.
Right? We didn't have to go this way. We can go that way, right? Because you know that's going to be one more, right? One more 100. All right, you're doing great. Roll again. It's getting bigger and bigger.
A 10 and a 10.
A 10 and a 10. Well, that's pretty easy.
What is up with the numbers?
That's actually, that would be great if those were they 10s or 20s? Those are 20-sided dice, aren't they?
Yeah, but I don't think oh, there was a 20 on them.
Yeah, you can tell which one's a 20. If you were rolling hits in D&D and you got 2 20s, you'd be a very happy camper.
Yeah, but there's 2 10s.
Oh, but they were just 2 10s. All right. Well, what's 10 times 10?
It's 100.
100. All right. Roll it again.
17 and 11.
17 and 11. All right. Let's pretend that the 11 is 31 and the 17 is 17. All right. Here we go.
Okay. So then, 1 equals 7.
What's that?
7 times 1 equals
I'll count the big ones first. 300.
300.
How many 10s?
There's 8 10. No.
Wait. How many 10s?
There's 1.
There's 1 10 there, but there's how many 10s there?
There's...
Just for that, I'm going to make you draw
10.
this. What's 7 times 3?
Oh. 21.
21 10s, and 1 more 10 is 22 10s. And what's 7 times 1?
7 times 1 is 7.
Alright, now you're going to have to draw this. Alright, so
527.
527 is the right answer. But I want you to draw it. So get a piece of paper. Alright, and I'm going to put it over here. So 100, 200, 300 across, and 1. And then 17 up. So this is a 7 block, this is a 7 block, this is a 7 block, and that's a 7 block. But when I say 7 block, I mean, uh-oh. Somebody's having an unpleasant day. I mean one of these, right? So 7, 7, 7. That's the 21, and then there's the extra 10 right there, and then there's a 7 block, and then 300s, which gives you 527.
Okay, now I'm going to write that down because I found the color pencil.
All right, excellent. But do you see where you can look at it in your mind and do it?
Mm-hmm.
Yeah. And you got graph paper, so that works nice. Try to be neat. Try to draw neatly. Stay inside your lines. Oh wait, that's not graph paper, that's filler paper. Alright, oh.
And then 300.
Alright, so these are red squares. Do I have a red pen around here? No, we got a black pen. I got a red pen, I got a pink pen. I can make it pink. Make it multicolored. 100, 100, 100.
Boom, boom, boom. Bing, bing. Done.
Alright, excellent. Okay, oh, you know what we could do?
What?
I'm going to change this into algebra. Same picture, but now we're going to name the blocks different things. Alright, so on the smooth side, what's this thing called?
Wait, which one are you pointing to?
This one.
Squared.
X squared, alright. So here's what I'm going to say. I'm going to change this into 3x, ooh, look at that black, that's pretty good, plus 1 times x plus 7. What do you get?
3x plus 1.
Right, it's at 1, 2, 3x plus 1, going that way, and then x plus 7 going that way. Can you count them? So how many red squares do we have?
3.
And what are they called?
X squared.
Okay, so 3x squared. Okay, now, how many x? Well, there's 1 x there, and 21 more x there, so how many x?
21.
Oh, wait a minute.
No, 20.
22x. See, and on this one it's easier because you don't have to add them up, right? You're never going to get x's adding up to x squares. And the 7.
Yep.
Anything hard about that?
Wait, what is the 7?
The 7's right there.
Oh.
Right? And we can do it. 3 times x is 3x squared. 3 times 7 is 21x. 1 times x is another x, so 22x, right?
How is it 22x if that's the
Well,
same?
7, 14, 21, 22. Oh, you got yours in colored pencils and everything.
X plus 7.
Right, because
X plus
look, there's 3x. Look, all right, hold on a second. Let's, as Mike, one student used to say, I'm going to draw my rainbows. There's my 3x squared. This is distributive theory of multiplication. There is my 21x. There's my extra x. And there is my 7. 1 times 7 is 7. So there they are. That portion comes first. This portion comes second, and that portion comes third. There are 3 different kinds there: x squareds, x's, and units.
Look, I should roll my pencil.
Yeah, why don't you write that down, just for fun?
Okay.
And it's the same picture, right? This is the same exact thing as 31 17 times.
What color should I use?
Oh, whatever color you want. Make it nice and colorful.
Okay,
Red, blue, and green is my favorite for these guys. If I should have a red pen. I gotta go find my. Really, I don't have a red pen. I got a green pen. I got boxes and boxes of pens. Oh my goodness. All right, there's another box. Yes, here we go. I got red in here. There's a red one.
So.
All right. Red. Oh, but my red is not very red. And then over here, I could use green for my units over here in the corner. Ugh. And then my X's will still be 10s, or still be blue, I mean. And when I do this over here, I get 500, right? 27. Bam, see them? 100, another 100, 27.
Yeah. Wait. 20.
Well, because if these are 22x, but when we're in base 10, that's 22 tens. That's 220. This is 300. And there's my 7. Add them all up, right? Do you see how algebra is actually easier than base 10 mathematics? Because I don't have to carry. I don't have to combine anything. I just got x squareds, x's, and units. All right, let's go. Let's make it. Are you ready to do another one?
Yeah.
All right.
I'm just gonna keep that in here and I'm rolling.
All right.
5, 14.
5 and 14. Oops, let's go this way. All right, now that's looking good. Finally, my camera stand's cooperating. Get these guys out of here.
5 times 14.
Get these guys out of here. That's super easy. Let's make it bigger.
It's 70.
Let's make it more fun. Wait a minute. You've got 5 and 17?
5 and 14.
5 and 14. All right. What's 14 times 5? That should be super easy. That would be 70, right? Yeah, like you said, 70. All right. So let's change it to 27 and 15.
Wait, you mean 24?
Okay, fine. 24 then.
Okay. And I will calculate that.
And you will calculate that. And then we can change it to 2x plus 4 and x plus 5.
Yep. Calculating.
Calculating. Can you draw that one fast one? Oh, he is drawing it. Excellent. I like it.
360.
All right, so let me see here. Do I have room? Yes, I do. I'm going to do this. I'm going to go the way they don't teach you in school. 200, 10, 14 tens, 20, 360, right?
Yep.
All right. And then what? Over here, I would have what? 2x squared.
So 2x
14x.
14x.
And
2x squared, 14x, and
what's 4 times 5?
20.
Done. See it?
Yeah.
Same blocks. Everything's positive. Anything hard about this?
140 is the 14.
Yeah.
The 200 is the 2.
Yeah.
Oh yeah, I see it.
All right, so I'm gonna draw it fast down here. I'm gonna draw this.
Oh, now I understand. Now I can do the next one quickly.
All right, you're gonna be able to do the next one fast in your head.
Yeah.
Because I'm telling you, being able to see these in your mind makes a big difference. Now this is gonna be 4 10s right here. That's gonna be a 5 and a 5. And in the corner, we'll use green.
So easy.
It is so easy, right? That's why your mom pays me to make your math easy. There you go. And see, my sons didn't understand until they finally spent a year in public school that they make math hard in public school.
200 is 2x squared.
Yep.
140 is 14x.
Yep.
And then 20 is 20.
Yep. There you go. All right, roll your dice. Let's do it again.
Wow.
Wow.
A 6 and a 10.
A what?
A 6 and a 10.
All right, let's make that. That's too easy. Change the 10. Roll the 10 again.
Okay, so
That's just 160, right?
14.
All right. So how about 14? How about we'll make this 6 36, and we'll keep that 14.
Okay, I'm gonna calculate that, but I don't know if I have enough room.
Oh, I'll change your page. Turn the page.
Oh, you're right.
All right, you know what? Hold on a second. Before you turn the page, let me take a picture of that. I'm going to screenshot that. Turn back the page, and I'm just going to take a quick screenshot. All right, hold it up, though. No. Toward the camera, you goofy. You're showing me the blank page, not the page that you wrote on. There you go. Just try to keep it still. Oh, my goodness. All right. Excellent. All right, go ahead. Right, you can use that same page right there. The one, yeah, that one. Yeah, why not? Flip it over. You know what I mean? Flip it over so it's not. Yeah, there you go. Perfect. No. So I mean, flip it over so that it's one page. So that's one. That's why it's a spiral. So you can make it so that it's just one page showing instead of open. There you go. Perfect.
36 times.
36. And then I put over here, I'm going to put, oops, oh my god, pens dropping everywhere. Alright, got it. So I'll tell you what, I'm going to do the whole thing.
And I'm gonna also.
I'm going to say that, I'm going to change it up. I'm going to turn it into the rectangle in one side is what I'm going to do. I have room? Yeah, I can actually even move it over. So the whole rectangle, oops. The whole rectangle is going to be what?
It's 504.
This side's going to be x plus 4.
504.
Alright, so what do we have? We have 300s, right?
Yeah,
12,
120.
18, right? 3 times 4 is 12. That's 12 tens. Plus 6 tens is 18 tens. And 6 times 4 is 24. So what do I have there? I'm going to have 3x squared.
504. It's 504.
I like it. You are correct. So
I did way different stuff than you.
I know. Well, what'd you do?
I had 200, 120, 16, 24.
Well, same thing. I just put my one. All you did, you broke this into 2 parts. You did 120 and 60. I just stuck them together.
Oh.
Right?
Well, I stuck 300 and 120 together.
Oh, so you did that all at once. All right.
Well, we stuck 120 and 60 together.
All right. There's 18x and 24. So look, there's the whole rectangle. What's the other side gotta be?
3x squared. 4x squared.
Wait a minute. What's the other side? If the whole thing is 3x squared, 18x, and 24, and one side is x plus 4, what's the other side have to be?
If one side is x plus 4, the other side has to be x plus 6.
Wow. How many x?
6.
How many x?
3.
3x plus 6. You are correct. Bam. How easy is that?
Easy.
Look, you're doing long division. But wait. If you have a teacher in public school, more than likely they won't say, okay, you're gonna have to show. You know, even at private school, they're gonna tell you, oh, you can't just do that. You have to show your work.
Yeah.
All right. So let's show our work. If I take the 3x times, well, we'll do this one piece at a time. If I take 3x times x plus 4, I'm going to wind up with 3x squared plus 12x.
Yeah.
Right? And then I'm going to wind up with 6x plus 24. And then I just do the plus 6, and 6 times x is 6x. And 6 times 4 is 24. Look, we're distributing. And then there's nothing left to count. Now here, I'll draw this for you. This is 3x squared. Right?
Yeah.
Okay. And then I'm going to be x plus 4 across. So these are 4. Oops. You know, I've got colored pens. I should use my colored pens. See if you can copy this. Draw this. Because what are we? That's my x plus 4 across. There's my x plus 4 across. And then, and see, that's this part right here. We just drew right up to here. That's the 3x squared plus the 12x.
Done.
Right. And then down here, I'm going to have, these should be red squares, not black ones. But anyway. There's my 6x, and then right here is going to be my 24. I just lost my red pen again. Here it is. All right.
Again?
I know, my red pen keeps trying to get away. Alright, so let's draw these. Alright. So see, we're doing drawing and not so much building with the blocks. There you go.
Okay, should I do another one?
Are you ready? Well, do you see what we did though? Did you write this? You didn't write this down. Write this down.
Oh, that part.
Yeah, this is a division problem. And all we're saying is, how many x plus 4s are contained in 3x squared, 18x, and 24? And what it says is, I don't know. 3 times. But there's 6 of them. And there's the drawing of it. And can you see that all we got to do is turn it like that, rotate like this, and then we'll have this one. 3x plus 6 and x plus 4. Shall I draw that over here? Do I have room? Yes, I have plenty of room. Oh, I need a better red pen. Oh well. Three x plus 4. See, I just drew it. I just rotated it here on this one, and then over here I've got those, and then over here is these, and I can show you the blocks that you're going to build with if you had. Right. So, what blocks would you need? You'd need 3 of these. You'd need either a bunch of 10s, and you have more than enough 10s to build this problem in your combo kit.
Okay, now
you could use one of these. Yep. You could use, if you had a deluxe combo kit, you'd have one of these, and then let's see here. You've got. Oh wait. You'd have 1, 2, 3, 4 of these, but you probably don't. You'd at least have 2, and then you could build another one with a 3 and a 1 or something. And then over here on the end, you'd have one of these. 3x plus 6, right?
Yeah.
Alright, or you could just build it, if you didn't have multi-10s, you could just build it with x squareds. You got multi-tens, though, don't you?
Wait, what are multi-10?
These guys.
Yeah, I have multi-10.
Yeah. Or you just build it with a bunch of these, right?
Yeah, that would work.
You need 18 of them. And you have way more than 18 in the combo kit. Alright. That was pretty fun. Did you draw these two pictures? Let's see. Oh yeah, you did. Alright, excellent. You ready
Should I do another one?
Yeah, let's do another one.
A 16 and an 11.
A 16 and 11. Alright, what's 16 times 11? Just right off the bat.
Okay.
In your head.
100, 106, 176.
Done. Good job. Alright, now let's turn into something more interesting. Let's see here. 16 and 11, let's make it, you want to get bigger? Let's go 46
Ooh, cool.
and 21.
Ooh.
Yeah, there you
I
go.
can still figure.
Yeah, we're getting big now. Yeah.
It's still pretty easy.
Yeah, it's still super easy. It's just double
Even
digit
the one.
multiplication. Yeah.
The one makes it easy.
Yeah. There you go.
It's really easy,
Good.
honestly.
That's what I want to hear. I don't want to hear you struggling and saying, "Oh, this is hard."
This is.
Remember, he's 7.
It's 900. Wait, oh, that's big numbers. That's really big numbers.
Yeah, there you go. Big numbers. How many hundreds? 8 hundreds, right? How many tens? Well, 12 of them and 4 more. What's...
1326.
Alright, okay, hold on a second. What'd you come up with?
1326.
Alright, let's see if I get the same thing. 800. And then let's see here. There's 12 tens and 4 more tens is
Yep.
16 tens.
Yep, which I got.
And then a 6.
I'm just adding them up in different ways.
I don't see how you got to 1300.
No, 1326 is the answer.
That's what I mean. I don't see how you got to 1300. I only have 800s. Over here I have another 160 in my tens. And then 6.
Wait, how I don't have the 1326?
So the idea is, okay, so here's what I want you to do. I want you to draw this. Because how do you get to 1300? You only have 966.
What?
What? Draw it. I'm going to draw it monochromatically. 100, 200, 300, 400. This is going to be a 60. Then I'm going to have 220, right? 2 tens up. That's going to be another 60. Right? And then I'm only 1, 1, 1, 1, 1. And then a 6. These are tens. Now I'm going to make it color-coded. Ooch.
What did I do wrong?
I don't know. You counted something extra.
Oh, that's a 40, not a 400.
Ah, there you go. That'll make a big difference, huh?
That's...
Alright, so then there's 6 tens and 6 more tens. That's 12 tens. 11, 12, 13, 14. Right? Oh, excuse me, 12, 13, 14, 15, 16. Yeah, there you go. I see what you... Do you see?
I'm right. Now I'm right.
Now you're right. There you go. And then there's my 6. I could do 1, 2, 3, 4, 5, 6, but actually that would probably be better.
Can I draw that?
1, 2, 3, 4, 5, 6. There you go. Sure, if you want to. Definitely draw that.
I don't think I have space on this page.
Alright, turn the page. And then you gotta draw a little smaller and a little neater. So when we get all of that together, I've got 966.
Alright.
Hundreds.
1, 2, 3, 4,
Tens.
5, 6. Should I roll the dice again?
Tens. 6. There you go. And actually I should make this, put 120 there.
I'm rolling the dice.
Alright, you ready to go? Alright, you're tired of this problem? Let's do it. I like it. Let's do another one. Done.
No. You never believe what I got.
What'd you get?
A 4 and a 6.
A 4 and a 6 again? Roll them again.
A 12 and a 13.
Ooh, what's 12 times 13? Just off the top of your head.
Oh.
That should be one you know.
156.
156, good job. And that could be the same thing as x plus 3 and x plus 2, which is x squared, 5x, and 6. Right?
Yes.
In fact, let's do that one fast one. X plus 3 times x plus 2 across and up gives me x squared plus 5x plus, jeez.
Yep.
5x plus 6. Alright, so let's make it funner, bigger. How about we make it like, 53, and 32. Oh my goodness, that's a big number.
No, it's not.
And let's tell a story. I have 32 bus loads, 53 kids in each bus. When I had 32 bus loads come, how many kids?
So, you had 50 bus loads.
I had 32 bus loads.
32 bus loads.
And I had 53 kids in each bus.
Okay, and how many kids were there?
How many kids were there? I'm riding in the bus. There's my bus, my school bus. Oops.
So it's 53 times 32, right?
Yeah. It's a terrible bus.
So,
Anyway.
what's 50 times 30? 50 times 30.
Alright, well, just count the big ones first. What's 3 times 5?
3 times 5 equals 15.
15 what?
That's 1,500.
1500. There you go. Here, I'll do red
That's
zeros
what I don't know,
just to make it fun.
32. So,
Now what? Wait, now what? Now 3 times 3 is 9. We're counting tens. And 2 times 5 is 10. So what's 9 tens and 5 tens? Oh, excuse me. I'm sorry. 9 tens and 10 tens.
I figured it out. It's 1,696.
I like it. He's ahead of me. All right. So 9 and 10 is 19 tens.
1,696.
And then at the very end, we just have 6. Super easy, right? There's nothing to do here, right? The biggest thing you had to do is add 1 and 5, right? Or add the 10 and the 9, which I messed up because I was saying 5, but I had 2.
100 and the 100 together.
Right, there you go. So 16, so you can go this way easily. 1,696.
Yeah, 1,696 because I put the 1,500 with the 100.
All right, so you'd have 1,696 kids show up, right?
That's a lot.
That's a lot of kids. So let's say I had 1,696 kids and I divided it by 53. How many, if I can put 53 kids in each bus, how many buses will I need? 32.
32.
Done.
Oh my god. The vision is so big.
But it's so easy, isn't it?
96 can go to 32.
Certainly. And if I change it around, if I said 32, if I only had 32 buses, how many kids would I need, be in each bus? Well, it'd have to be 53, right? Let's do the math.
Yep.
Let's do the show the work part. What's 3 times 53?
3 times 53 is 159.
All right, I like it. But this is 30, right? So it's 1,500, right?
Yeah.
And 9. D.
Yeah.
Right?
Yep.
Because this is technically that's 30. It's not just 3, but making it easy.
30.
All right. So bam, 1,590. And do you see I'm just rearranging these guys over here? So what's left? 106.
Yep.
And then what? And then I do this 2 times, and I get 106, and there's nothing left to count. Easy? Is that easy?
Yeah.
You know how many kids I have? Well, I don't have any kids. But even my own son was telling me that he doesn't like long division.
He doesn't?
Yeah. On a happy note, the younger boy was the #1 kid in his group of 150 on the, out of 150 kids, he got the highest score on the PSAT.
Oh. What about, wait.
And he said he wasn't even trying.
You have one son, right?
I have 2 sons, just like your mom.
Oh, so your younger son got the
highest score in his group. I don't know if he got the highest score in his grade, but he was definitely in the top 5 or so in the whole grade.
In a whole 50 people?
In his group, there was 150 people, yes.
That's impressive.
Yeah. And it wasn't close either. Like the #2 person was pretty far behind. All right, are we ready to go? Another one?
Yep. Cool.
Oops. Throw them on the table, not on the floor.
A 20 and a 12.
A 20 and a 12. That's kind of boring, but all right, let's do it. Just for fun. What is 20 times 12?
20 times 12 is... So it's...
This is one where it actually might be the other way around would be better. If I did 12 20 times. Well, then it's just 240, right?
Yeah.
Right? Because it's like 120 twice, or I don't know, 2 times 12, put the 0 on there, or however you want to do it. But it's still just 240, no matter how you dice it. All right, another one. And then let's call it a day. We're at the end of the hour. You guys you got a little less than an hour today.
8 and a 13.
An 8 and a 13. Let's make this one crazy. How about we make that 68, and instead of 13, we'll make it, pick a number between 1 and 4.
1, 4, 2.
All right, so we'll make it what was the other one?
It was 16 and... Wait, I forget.
Oh shit! We've got short-term memory failure going on here. All right, roll one more time. Just roll 1 dice.
Oh, 1 dice?
Yeah.
8. No, 6.
6. All right, let's call it 6, and then roll another dice. One more time.
6.
Oh my goodness. All right, let's do 66 times 68. That's a pretty fun number.
66. So then 60 times 60 is
6 times 6 is?
6 times 6 is 3,600.
There's 3,600. There you go, right? 36, but we're counting, these are tens, so it's 100. Then what? Another 36 and 48. What's 30? I'll do those in two groups. 36 tens and 48 tens, right?
I found the 360 and then 60 times 8, which is 480.
Right, there you go. And then what's 6 times 8? One more time. 6 times 8 is 48, right?
Yep.
Alright, now you got a little work to do.
30.
So we could combine these, but never mind. We'll just go. Ooh, gnats. You're gonna go this way or this way?
I'm gonna go this way.
Alright.
Right, left.
Alright, so can you see that you're gonna have one extra 10 there, right? So that's a 4.
Yeah.
Right? And then
Yeah.
you're gonna have another extra 10 here, right?
Yeah.
So that's a 4. And then what? That would be 8. And that would be 8.
4.
That's a kind of fun number, 4488.
It's 4,488.
There you go. Good job.
I put that out on this.
Yeah.
I was looking.
Or you could go the slow way and you get 8. And then I got 10, 18, carry 1. And then I got
That's so cool.
14, carry 1. And there you go. Right?
I just did this way, the addition, and then plus the 48. Because
There you go. See, and then we could do all kind of fun. We could make this into a division problem. If I had 400 4,488 divided by 68 is 66. Right?
Yep. And other way around is 68.
Right, there you go. All
And
right.
then that unit is 4,448.
Okay. Oh no, I was off screen. I was off screen this whole time. Oh no. I just noticed I wasn't high enough up. I was looking. He was fine with his, but not with you guys. Anyway. All right. Well, Crewton Ramone's HouseOfMath.com for more.